4 notes, part 2. So just to show you know from the example we started on part 1, and then we have one more example show you know. So not very long to do, but like a little bit more challenging stuff. Okay, so let's see here. I'm going to show you the setup, and then you can just kind of tell me if you see something different or if you don't understand what I got. Okay, so we have, let's see here, kind of right. There we go. All right. Internet Cafe A charges $1 for 15 minutes, 20 cents per page for printing. Internet Cafe B charges $2 per hour and 25 cents per page for printing. Suppose you want to use the internet for 1 hour. Okay, how many pages do you need to print to make cafes equal price? Okay, Luke, I'll be good for a little bit. I'll call on you when I need you. Okay, so a couple things I want you to kind of highlight, understand. I hope that you understand that these are your two equations, Internet A and Internet B. Those are your two different equations. Okay? The other thing I want to point out is it's fairly important to understand pertinent information. Obviously, 1 for 15 minutes, 20 cents per page, $2 per hour, 25 cents per page. The one thing I want to point out is that notice this is in hours and this is in minutes. So they are not the same time. Okay, that's an issue. So if you just set that up as $1 and $2 that's wrong. Because you're saying X is the same time. It's not. One's an hour, one's a minute. What's important, guys and gals, is that it tells you this. You want to use it for 1 hour. So it tells you that, so now your time is no longer a what? We'll correct that and what, though? It's no longer a variable, because a variable represents something we don't know. We know how long we're going to be at the cafe. So our variables now is what? What's our variable?
How many pages?
Pages, right? Number of pages. So this now is our variable. Does that make sense? Time is no longer a variable. They tell us how long we're going to be there. Okay? So let's just set these up here. All right, so P, they tell us, is the variable we want to use. So if I go, I'm going to just do the A equation and the B equation, and we'll set them equal to each other's last. So if it's $1 for 15 minutes, how much is it for an hour? $4. So $4 plus 20 cents P is Internet Cafe A. 0.20p plus 4. Yep, I prefer it that way myself, so yes, for sure. Okay, B charges $2 per hour, so I write just a 2 because we're talking about an hour. Okay, plus 0.25p. Okay, how many pages do you need to print to make the cafes equal in price? Okay, so are you going to tell me how to do it, or are you going to tell me the answer? Okay, so hold on. Okay, why don't you tell me how to set it up? So if they want equal in price, just tell me the setup, Luke.
So you put 4 plus 0.20p equals 0.25p.
Okay. So you're good right there. Just pause for a second, then I'll let you tell me next. So now what we have here is this is Internet Cafe A equal to Internet Cafe B. So it wants to know when they're equal in price, so we're setting their charges equal to each other. And we want to figure out what P, so what page amount are they equal in price. Why would that, in general terms here, okay, why would that be important? Like, let's say you're trying to figure out which cafe to go to. I know this is, not quite realistic maybe. But why? How could that help you? Someone besides Luke. Which one's more cost effective? Or, no, let's say you're planning on being there for 20 minutes. So then you can kind of figure out, well, which one for 20 minutes is going to be helpful. Or maybe I'm going to print 10 pages. If I'm only going to print 10 pages, which cafe do I want to go to? Okay, those type of things will be helpful. Okay, so then Luke, what's your next step here in terms of solving? Okay, good. So we minus a smaller p, which is good. So this step here, and just to kind of go off of yesterday, a lot of you guys did a poor job of explaining your steps. You just said isolate the variable. That doesn't tell me, when I give you a steps problem, and we'll go over this in a second, and you're explaining your steps, I should be able to follow it like a roadmap and get to the answer. Okay? That'd be like saying, I live in Calgary, just drive to Calgary. Oh, okay. Cool. I'll find you. I'll get there. Thanks. Okay? So be more specific in your steps. So for example, if I was explaining this, move the smaller p. Just like I say, move it over. Okay, so we did that. Perfect. There we go. Now we minus the 2, right, Luke? Divide. But it's going to make it bigger. Okay, so 40. So that means, what that represents, at 40 pages, they're equivalent. So if you know you're going to print 40 pages, you can go any place you want. If I'm going to print 100 pages, where should I go, Aiden?
Probably number 1.
Yeah, A, right? Because they charge more up front, but the pages are cheaper.
Yeah.
So if I'm going to print 100 pages, I'd rather go here. Okay, if I'm going to print 10 pages, I'd rather go here. Okay? Any questions on that show, you know. Okay? All right. So, example 3, solve and check. So here, we don't like the fractions. Okay, we've kind of talked about this idea a bit. If you don't like fractions, we do have a strategy to get rid of them right away. What is that? Do you guys remember? Common multiples, right? That's the part a couple of you guys are asking. Remember you asked about common multiples in the packet? Remember, they're all over that. So what's a common multiple of 3 and 2? 6. So I can multiply both sides by 6, and that'll get rid of my fractions. If you don't know what a common multiple is, guys, that's a number that the two numbers go into. So 3 goes into 6 and 2 goes into 6. The reason that's helpful is because what's 6 divided by 3? Yeah, so this is no longer a fraction. It's 2. 6 divided by 2 is 3. And see, now we're in a little bit better place. You may not be as confused now. You feel a bit more comfortable. Okay? Yes, sir? Yeah. Yeah, so let's distribute everything out. So we'll go distribute this out. 4x minus 2, 9x plus 3. Move my smaller x, minus the 4x over. Now move the 3 and divide 5. Okay, I'll pause there. I did those last parts a little bit quicker, but go and take a look there. See if there's anything that loses you. Okay, I'll pause the video for a second. Is there any questions? Okay, so on the show you know down here, this is the one that I think might kind of help with some clarity of when to cross multiply. It's best to cross multiply when you have it set up in the form of fraction equals a fraction. Because again, we don't like fractions. We want to get rid of fractions. Okay? So this is a fraction equals a fraction with variables on top of both. What I want to do is, essentially, again, it's hard for me explaining different this, and I know it's hard to understand, but we take this 2 and we put it right there, just in front. Cross it over. Then we take this 4 and we put it right here. Now by here, I mean it looks like this. So see this 4? It's going to be like that. 4 times what was on top of the right. Equal to 2 times what's on top of the left. So you can see the 2 is here multiplied to 3f plus 1. The 4 is here times the 3 plus 2f. And we no longer have fractions. Take a second, digest that. Is there questions with that? So again, maybe write a note on the side here. Best to cross multiply when fraction equals a fraction form. Okay? I mean, just to be honest with you, just in Math 20, grade 11, this one you guys could have done was easy. It was on a review, and some of them got it wrong. Okay? It was x over 5 equals 2 over 7. I could solve that by cross multiplication. Okay, I'm only putting this up here because it's similar to what you're doing right here. Yours is actually harder. I was on a Math 20 review. I go 7 times x, right?
Yeah.
5 times 2. Now what? You're done. Congratulations, you just did a Math 20 problem. Okay, you guys can do that. Okay, you guys can do that. All right, so let's finish that though. We're not done. I know you're saying, well, are you done? Nope, we got to do all the distributing and all that stuff now. Okay, 6f. Emily, are you scared because that's Math 20? Yeah? So we're there. Okay. Duthie, what do I do next? You met your quota today. Good job.
Now you minus the 2.
You can, sure. Okay. So let me ask you a question though, Duthie. When you're at this step, see how we have an F, a 2, a 12, and an 8F? We really want to get the F's together first before we move the 2.
Okay.
So what F would you want to move? 6F. Good. We'd minus this one because it's smaller. So minus 6F, minus 6F. Good. Gone. Your 2's there. Okay, Kale, what do you think now?
U minus 12.
Minus 12. Good. Finish it off there, Chance. Divided by 2. -5 is F. Let's go ahead and check it. It says solve and check. So let's go ahead and check it really quickly. So I'm going to erase what's up here. You can do these mentally as well. Okay, like for example, when I say mentally, like Tor, what's 3 times -5? So I have -15 plus 1 over 4. Okay, and then what is, Nolan, what's 2 times -5? -10, right? So we have these here. That's plus a negative. It just means minus. It's no big deal. -15 plus 1 is -14 over 4, which is -7 over 2. 3 plus a -7, or 3 plus a -10 is -7 over 2, which is what we got on the other side. So we just verify that those are equivalent. Therefore, it's correct.
How did you get -15?
-15? 3 times -5. I plugged in the -5. Yep.
Okay.
Yep. Plug in -5 for F. Good question. Good question.
So you're getting 4.
Oh, yeah. Any other questions on the 8-4 notes before we close that up? We're going to go to our problem of the day yesterday and go over that next. We're good? Okay.